An engine is a machine designed to convert one form of energy into mechanical energy. Heat engines burn fuel to create heat, which is then used to do work. It is a complex machine built to convert heat from burning gas into the force that turns the wheels. The chain of reactions that achieve that objective is set in motion by a spark, which ignites a mixture of petrol, vapor, and compressed air inside a momentarily sealed cylinder and causes it to burn rapidly. The engine has two types. One is the internal combustion engine, and another one is the external combustion engine. The internal combustion engine is those heat engines that burn their fuel inside the engine cylinder. External combustion engines are those heat engine that burns their fuel outside the cylinder. The engine is one of the most essential parts of the automobile industries, or we can also say that the engine is the heart of an automobile. So, in this video, we'll take a look at the function and construction of each engine parts of an internal combustion engine. So be sure to like this video, subscribe to the channel and press the bell icon to get notifications of our new videos. The main parts of a car engine are cylinder block, cylinder head, oil pan, manifolds, gasket, and piston. A piston ring, piston pin, connecting rod, crankshaft, camshaft, flywheels, rod bearing, main bearings, and bearing caps. Now let's take a look at each of engine parts with details, starting with cylinder block. It is the basic framework for the engine and one of the main part of an engine. A cylinder block consists of three parts: the cylinder in which the piston slid up and down, the port or opening for the valves, the passages for the flow of cooling water. The cylinder block is usually made of gray cast iron or aluminium and its alloys, while the crankcase is fixed to its bottom. Apart from these, other parts like timing gear, water pump, ignition distributor, flywheel, fuel pump are also attached to it. Coolant passages are provided in the cylinder walls for the circulation of cooling waters. Cylinder block also carries lubrication oil to various components through drilled passages, that is called oil galleries. Cylinder head. The cylinder head is another main part of an engine. It is a joint between the cylinder head and cylinder block. It is usually made up of cast iron and aluminium alloy. The cylinder head is attached to the cylinder block using studs fixed to the block gaskets, which are used to provide a tight leak-proof joint between the head and block. The cylinder head contains a combustion chamber above each cylinder, and it also contains valve guides, valve seats, ports, coolant jackets, and threaded holes for spark plugs. It incorporates passages for the flow of cooling water. There are three different types of cylinder head is available that depends upon the valve and port layout: loop flow type, offset cross flow type, and inline cross flow type. In the loop flow type, the inlet and the exhaust manifolds are on the same side, which facilitates preheating of the intake air. In the offset cross flow type, the inlet and the exhaust manifolds are placed on different sides of the cylinder head. In the inline cross-flow type, the valve is positioned transversely and usually inclined to each other, while the inlet and the exhaust manifolds are on different sides of the cylinder head. This arrangement gives better performance, but it is costlier. Crankcase. The oil pan and the lower part of the cylinder block together are called the crankcase. It is the bottom portion of the cylinder block in which the crankshaft is fitted. This is a rigid construction made of gray cast iron or aluminium. Either it can be cast integrally with the block, or can be cast separately and attached to the block with bolts. The crankcase is shaped simply like a box, having no bottom surface. The function of the crankcase is to provide support for the main journals and bearing of the crankshaft, rigidly maintaining the alignment of their axes of rotation under various engine loads. Oil pan. The bottom half of the crankcase is called the oil pan or sump. It is attached to the crankcase through set screws and with a gasket to make the joint leak-proof. The oil pan serves as a reservoir for the storage, cooling, and ventilation of engine lubricating oil. At the bottom of the oil sump, a drain plug is provided to drain out the dirty oil at the time of oil replacement. Generally, the sump is made of pressed steel sheet, or aluminium alloy casting is also used. The oil pump in the lubricating system draws oil from the oil pan and sends it to all working parts in the engine. The oil drains off and runs down into the pan. Thus, there is a constant circulation of oil between the pan and the working parts of the engine. Manifolds. There are separate sets of pipes attached to the cylinder head, which carries the air-fuel mixture and the exhaust gases. These are called manifolds. It is generally made of cast iron, so that it can withstand the high temperature of the exhaust gases. Gaskets. Gaskets are used to provide a tight-fitting joint between two surfaces. Gaskets are found in the joint between the cylinder head and the cylinder block, between the crankcase and oil pan, and in between the cylinder block and manifold. Materials used for gaskets are cork, asbestos, rubber. Gaskets produced by the Fuel Pro USA are cylinder head gaskets, oil pan gaskets, manifold gaskets, and pump gaskets. Cylinder liners. The cylindrical shape liners are used to avoid the cylinder wear. It is one of the most important functional part to make up the interior of an engine. Cylinder liners can be replaced after they are worn out. These are made of special alloy iron, containing silicon, manganese, nickel, and chromium. Usually these are cast centrifugally. These liners resistance to wear and corrosion, and are the oil hardening type that offers considerably longer life for the engine. There are two types of cylinder liners will be available. They are dry liners and wet liners. Dry liner is made in the shape of a barrel with a flange at the top, which keeps it into position. The entire outer surface bears against the cylinder block casting, and hence, these are machined accurately at both outer and inner faces. Wet liners will be in direct contact with the cooling water at their outer face. Because of this, these liners need not be machined very accurately at the outer surface. However, they have been machined accurately at the inner surface. Pistons. These are the most important engine parts compared to others. The piston is a cylindrical plug that moves up and down in the cylinder. It helps to convert pressure energy, obtained by the combustion of fuel, into useful mechanical power, and it transfers this power to the crankshaft through the connecting rod. The highest position of the piston reaches in the cylinder is called the top dead center, and the lowest position it reaches is called the bottom dead center. It is provided with about 3 to 5 piston rings that provides a good seal between the cylinder wall and piston. The efficiency and economy of the engine is primarily depend on the working of the piston. The material used for the piston is mainly cast iron and aluminium alloy. It may be either cast or forged. The piston is usually small in diameter than the bore of the cylinder. The space between the cylinder and the cylinder wall is called the piston clearance. This piston clearance provides a space for a layer of lubricant between the piston and cylinder wall to reduce friction. Generally, piston clearance is 0.025 mm to 0.100 mm. Piston rings. The piston rings are fitted into the grooves of the piston to maintain a good seal between the piston and the cylinder wall. The function of piston rings is to form a seal for the high-pressure gases from the combustion chamber entering into the crankcase. The material generally used for piston rings is fine-grained alloy cast iron containing silicon and manganese. It has good heat and wear-resisting qualities. Mainly there are two types of piston rings available. They are compression rings and oil control rings. The number of piston rings used is about 2 to 4 compression rings, and 1 to 2 oil control ring was used. Connecting rod. It is fitted in between the piston and crankshaft. The main function of the connecting rod is to convert the reciprocating motion of the piston into the rotary motion of the crankshaft. Connecting rod in an IC engine must be light and strong enough to withstand stress and twisting forces. It usually has I-beam cross-section and is made of alloy steel of duralumin by drop forging. The small end of the connecting rod has either a solid eye, used to connect the piston, by the piston pin. The big end of the connecting rod is always split, and it is used to connect the crank pin of the crankshaft. Piston pin. The piston pin is also called wrist pin or gudgeon pin. It is used for connecting the small end of the connecting rod and the piston. It is made hollow to reduce weight, and it is made from case-hardened steel. Mainly there are 3 types of piston pins available. They are set screw types piston pin. This pin is fastened to the piston by a set screw. Semi-floating piston pin. It is fastened to the connecting rod with the clamp screw. Fully floating piston pin. The pin floats in both the piston bosses and the small end of connecting rod. It is prevented from coming in contact with the cylinder wall by 2 circlips. Crankshaft. The crankshaft is the engine component from which the power is taken. It is one of the main power transmission sources in all engine parts. It is the first part of the power transmission system, in which the reciprocating motion of the piston is converted into the rotating motion with the help of connecting rod. The crankshaft is made of casting or forging of heat-treated alloy steel and is machined. A crankshaft consists of crank pins, weds, balancing weight and main journals, and oil holes. The front end of the crankshaft carries 3 devices. They are a gear that drives the camshaft, the vibration damper to control torsional vibration, and the fan belt pulley. This pulley drives the engine fan, water pump, and generator with a V-belt. The rear end of the crankshaft carries flywheel. The flywheel tends to keep the crankshaft running at constant. Camshaft. A camshaft is a shaft on which cams are mounted. A cam is a device that changes the rotary motion of the camshaft into the linear motion of the follower. It is responsible for the opening of the valves. A camshaft has several cams along the length. The camshaft is driven by the crankshaft, and it has twice the gears as many teeth as the gear on the crankshaft, and it turns at half the speed of the crankshaft. Camshaft made from forged alloy steel. There are 3 types of the camshaft drive mechanism. They are gear drive, chain drive, and belt drive. Flywheel. The flywheel used in a transmission system of a vehicle. A flywheel is a heavy steel wheel attached to the rear end of the crankshaft. The size of the flywheel depends upon the number of cylinders and the construction of the engine. The inertia of the flywheel tends to keep the running of the crankshaft at a constant speed. Engine valves. These are essential to control the timing of air-fuel mixture, entry into the cylinder, and combustion products out of the cylinders. Engine valves are located at the inlet and outlet opening of the engine cylinder. The valves fit on the valve seats, in their closed position. That's it. Thanks for watching. If you want to download the PDF, check out the link in the description. If you like this video, then please share it with your friends. Subscribe to our channel and press the bell icon to get notification of our new videos.